Hello everybody, my name is Eloise and this is Refillware.
Hi everyone.
In our previous lessons, we noticed some interesting changes to the x and y values as we reflected points, lines and shape about the axes. Remember how the x values stayed the same while the signs of the y values changed when we reflected shapes about the x-axis. And when we reflected about the y-axis, we saw the opposite happened. This time, the y values stayed the same, whilst the x values changed signs. Well, today we're going to spice things up a bit. We want to see what happens to the x and y values as we put our mirror line exactly in between the x and y axes. Let's investigate what happens to the x and y values as we reflect points, lines and shapes about the line y equals x. By the end of this lesson, you should be able to reflect a point, line or shape about the line y equals x and identify the coordinates of points, lines or shapes that have been reflected about the line y equals x.
So what do I get to do today?
I'll need you to do some drawing and folding for me. Do you think you can manage?
Drawing is cool. What do I get to draw?
Well, you can start by drawing the line y equals x onto the Cartesian plane for us.
The line y equals x is the line where all the points on the line have the same x and y coordinates, right?
That's right.
That means if x equals 0, then y equals 0. This point is at the origin. If x equals 1, then y equals 1. So I'll plot this point here. Let me see just one more point to be sure. If x equals -2, then y equals -2. So I'll plot this point here. Now all I need to do is join all the dots with a straight line like so. That's it, all done.
Next, we'll do some paper folding. Fold the paper along the line y equals x and open it up again. Now choose a point that is not on the line y equals x.
I'll choose 2, 3.
Take a marker and plot the point on your paper. Label it R. Now fold the paper along the fold line towards the point you chose. Can you see the point you made through the page?
Yeah, here it is. I see what you mean. This point will be the reflection of the point I chose.
Can you tell me what the mirror line for this reflection is?
The fold is the line y equals x. So I've reflected about the line y equals x.
That's right. Now for the moment of truth. Open up the piece of paper. Look for the reflected image and label it R prime. Good. Now tell me, what are the coordinates of the new point?
They are 3, 2. What's so special about that? Now I really don't get it.
Maybe you need to see another point before you see why this is special. Try -4, 2. Plot it on your paper, label it P, and reflect it as you did just a moment ago. Then tell me what the coordinates of the new point P prime are.
Okay, so I plot -4, 2 and fold the paper. Then mark the point showing through the page. Open it up and the coordinates of P prime are 2, negative 4.
Do you see a pattern yet?
No, not really.
Okay, let's compare the coordinates of each point with its reflection. R was 2, 3, and R prime was 3, 2. And P was negative 4, 2, and P prime was 2, negative 4. So, what do you see? What relationship do you see between the coordinates?
Oh, I see. The x and y values have swapped places.
So when you reflect a point about the line y equals x, the x value of the reflected point is the same as the original y value, and the new y value is the same as the original x value. This gives us a quick way to find the reflection of any point about the line y equals x. Just exchange or swap the x and y values and plot the new point.
Let me try that out with another point. I'll choose the point negative 3, 5. I'll call it n. So by a quick method, the reflection should be 5, negative 3. I think I should test this on my squared paper.
Excellent idea. Don't trust a short method until you have confirmed it with something that you know works.
Right. So I plot the points, then fold along the line y equals x. Then I copy the point and unfold. Let's see. The reflection comes out at 5, negative 3.
Great. That's what we worked out with our short method. If you were to try this out with more points, you would see that it really does work every time.
We still have to do reflecting of a line and a shape.
True, but I have a surprise for you. You have basically done it already.
I have? I don't get it. How?
Don't look so worried. I'll show you what I mean. In a few moments, I think you are going to appreciate what I did. Let's work on the board from now on. You add 3 points, R, P, and M. And you found their reflections R prime, P prime, and M prime. So let's make a line segment by joining R and P. Can we reflect this line segment? Well, we know the reflections of R and P already. They are R prime and P prime. If we join R prime and P prime, we have the line segment R prime P prime, which is the reflection of RP.
If we join R prime and P prime, we should get the line segment R prime P prime, which is... that's so cool!
I thought you'd like that, but that is not the best part. If I were to join R to M and join P to M, I would get a triangle.
A triangle? I get it. So now we have a shape that we're going to reflect, which should be quite easy, seeing as we know the reflections of each of its vertices. Very clever.
You are starting to read my mind. Let's see if this idea works. Join R prime to M prime and join P prime to M prime, and we get the reflection of the triangle. So we reflected a whole lot of lines and a shape without having to reflect every single point on the triangle separately.
Wow, that's pretty amazing.
Isn't it? What I wanted you to see is that a shape or a line is reflected by reflecting its vertices or endpoints and then joining up the points. But there is something more that I want to show you about reflections. Have a look at what we did in a previous lesson. We reflected points in the x-axis and joined each point to its reflection. We found that the line joining a point to its reflection was perpendicular to the x-axis, and each point and its reflection were equal distances from the x-axis. Now the question is, will we find the same thing about points reflected about the line y equals x? Let's test this idea with one of the points we have already reflected in this lesson, point P. P was -4, 2, and its image P prime was 2, -4. Drawing a line joining P and P prime like this, measuring the distance from P to the mirror line, we get 4 centimeters, and the distance from P prime to the mirror line, we get 4 centimeters. So these distances are equal. Now, measuring the angle between the line P, P prime, and the line y equals x, it is 90 degrees. So the line P, P prime is perpendicular to the line y equals x. So these distances we measured are on a line which is perpendicular to the line y equals x. You will find that that is true for all reflections, no matter what mirror line you choose to use. The perpendicular distance between a point and the mirror line or line of symmetry is the same as the perpendicular distance between its image and the line of symmetry. Let's look at what we did today. We reflected a point, a line segment, and a shape about the line y equals x. And we found that when you reflect a point about the line y equals x, the x value of the reflected point is the same as the original y value, and the new y value is the same as the original x value. So the reflection of a point A, B has the coordinates B, A. Lastly, we saw that if you join a point and its image with a line segment, then that line is perpendicular to the mirror line. Also, the point and its image are equal distances away from the mirror line. Now I think it's time for today's task. If A, 1, 5, B, 4, -2, C, -2, 2, and D, -3, 4, are vertices of a quadrilateral, give the coordinates of A prime, B prime, C prime, and D prime, and use coordinates to sketch A, B, C, D, and A prime, B prime, C prime, D prime. So, Refilwe, are you confident that you can do reflections about the line y equals x?
I think so. But I think I should just try some other examples in my book.
A good idea. But I think we are finished for the day. So, goodbye.
Bye.